Okay, Common Core Algebra 1, we are going to start our next unit, which is going to be all about something called quadratics, which is probably going to be new for a lot of us. So today, in this video, you're going to get a lot of terminology about the vocabulary of quadratics that are new to us. We'll talk about what are the key parts of a quadratic graph, which we're going to do a fair amount in this chapter. And then finally, the three forms of a quadratic function. So there's going to be three different forms, kind of like there was standard and slope-intercept form for a line. So first set of vocabulary words, a quadratic, first of all we want to know what it is an algebraic expression where we have an x squared term. So that squared term is what makes it a quadratic. And that quadratic is going to create a parabola, which is a U-shaped graph. So it's either going to open up or down. And the vertex is the max or min on the point of the graph. So if you think about your U-shaped graph, your vertex is going to be right there. This would be the minimum. Or if our U was the other way around, then that vertex would be the maximum. So one of those is your vertex. And then y-intercepts is nothing new for us. It's just the point where the parabola crosses the y-axis. There will always be a y-intercept. And then we've talked about zeros, which are also called the x-intercepts, or sometimes you hear them referred to as the solutions or the roots. And there's not always this. Okay, so we don't always have a zero or an x-intercept. We do always have a y-intercept. Continuing on with our terminology then, this is again some stuff that we touched upon right at the beginning of the year. Domain and range. Domain are our input values, our x values for which we have a graph. And range is going to be our y values for which we have a graph, or our output. Okay, the x values for us in this case are going to be all reals, meaning every number that you guys have ever worked with is going to be a value that x exists or that we'll have a graph for. Our range, this one, is going to be limited in one way or another, and we'll talk about how that limited looks, and we'll even talk about how to write what it looks like. So our symmetry then is going to be present in every quadratic, and it's an ability in this case for our quadratics to fold a graph and it will look identical. So if you think about your U, if we drew a line right down the middle, we could fold it in half. They would be identical on each side of that line. And that line that we would draw is called the axis of symmetry. And it's important that we recognize that it goes through the vertex, and so it creates two identical pieces of the parabola. Okay, some example of some of those terms we've talked about, then you'll see your vertex is the min in this case, and that's going to be at point 2, -5. And our zeros are our x-intercepts. So you see we have two there. One here at -1, 0, and one at 5, 0. So in this case we had 2. Sometimes we could have 0. Sometimes we could have 1. Our y-intercept is going to be the point where we cross the y-axis in blue right here. And we see that that is at 0, -3. For our y-intercept there's always only 1. For the zeros there could be 2, 1, or 0 of them. Now these are not the actual values, they're just how many of them exist. And then finally our axis of symmetry, the way that's going to be written, it's always going to be x equals something because it's a vertical line, and you'll notice it goes right through your vertex, so it's always the exact same as whatever your vertex x value is. So this 2 is what told us our axis of symmetry was x equals 2. And you'll notice that it is identical on each side. So for example, you can see that in your x-intercepts. If we are 3 units to the left, our other x-intercept is 3 units to the right. Likewise, even in your y-intercept, we could find another point here where 2 units to the left, we could go 2 units to the right. And another point on our parabola would now be at 4, -3. Okay, the three forms we have then, so the first one is just going to be f of x, and remember we talked about this at the beginning of the year. It's called function notation. It essentially means the same thing as just y equals ax squared plus bx plus c. We're going to use a lot of f of x in this chapter. You will see some y as well. And so this is just when we have a, b, and c are some numbers. The variables stay as x and y. Okay, the next form we have is what is called vertex form. And so this is going to look a little bit different. A, and then in parentheses, x minus h squared plus k. Again, a, h, and k are real numbers. And in this case, called vertex form, not trying to fool you, the vertex is hk. So we just take that value h and take that value k. Now you notice here, it's x minus h, and here it's a positive h. So that h switches signs. whereas k is positive here and it stays positive here. So h hates its sign is what we say, k keeps its sign. And the last one is our intercept form. F of x equals a, and then in parentheses x minus p times the other parentheses x minus q. Again, a, p, and q are real numbers, and p0 and q0 are the x-intercepts. Also, we call them the zeros, or the solutions, or the roots. And so that is it for our introduction to quadratics. Next time in class, we will look at some graphs and identify all these important parts that we've seen today, and we will start to work with some of our forms and how we're going to manipulate those to create graphs. All right, see you next time.